Hello, welcome to SINCON 2021. Well, we did the same thing earlier this year, but that is for 2020, and this is the second time for 2021. And we do make a wish that, after at least this year, we're supposed to have a real conference, and unfortunately, we are still here. So, okay, okay, this is me. All right, I'm from this Chinese version of Amazon called JD. All right, I also the founder for Chilling Framework. Uh, I also run this small little project called Batch Maker. We design batch for security conferences and a few other friends party. All right, and this is some of the list of the talk that we have joined. I mean, you can see it's quite not updated, and well, it's yeah, supposed to be that way. Okay, my the other partner, Kabor, he's the core developer of Chilling, and he's the one that code most of the most. When I say most, it's 99% of the smart contract part. Uh, I am the chief designer, and he's the chief coder. So this is how we put it. All right. So all right. For the newcomers that if you haven't heard about chilling before, this is a very quick introduction to chilling. The entire idea itself, we wanted to make IoT reverse engineering great. All right, not a game, but great. You know what I mean. Okay, so the one of the biggest issue with IoT analysis is you need to have the actual hardware in order to do the analysis. So the reason why it's the instrumentation layer in the entire IoT analysis, it's not convenient. It's not designed for IoT yet. It's not designed for or IoT analysis, especially like people like us for reverse engineering. So just for a quick example, if you wanted to go into a mass variety of car analysis, first of all you need to have the devices, or else it's gonna be too expensive. It's gonna be too tough for you to do analysis. So how do we fix this? How do we fix it with Chilling Framework? Is when we started the entire IoT analysis, we did a talk in a couple of conferences in year 2018. We do bump into a lot of issue whereby devices is the hardest thing to emulate. You have things like audio, screen, even things like a GPS, cam. How can you emulate those devices in a very easy way for you to comes into for you to make a tools to emulate all these devices. So the entire idea of a chilling framework is we wanted to bring firmware emulation with comes with an instrumentation. Then we can make use of the instrumentation, the API plugin to build virtual device support. Like what I mentioned just now, you do have a couple of virtual machines that are able to do that. If you patch QEMU here and there, you will be able to do that. Create some fake devices. Try to emulate some Bluetooth devices. It's possible, but we wanted a thing that can do things on the fly. But there are still a lot of things that QEMU or even Bosch can't able to emulate that kind of stuff. Like Qualcomm's EDL, you wanted to do emulation with instrumentation, it's totally not possible. UEFI, it's one of the pain for reverse engineer. We are talking about a bootloader. We are talking about anti-debug, anti-debug, and master boot record. And of course, the topic today is we're gonna focus on smart contract. So before we goes into a smart contract, there are a few things that we want to do with Chilling's framework introduction. So first thing first is these are most probably the platform that we are supporting. When I mention most probably, the only reason it's we are looking at the things that we know. If I miss out something, that could be a very high possibility I lost count some of the features and functionality. Okay, so we are purely solely based on Unicorn engine as the lower layer engine to do the CPU emulation. All right. So and then we build chilling engine on top of it. So what you can think of is chilling engine. It's part of the Unicorn engine is the CPU emulator. Chilling engine is the OS emulator. Then from chilling engine, we do have a layer that you can emulate different kind of hardware. Then that is where the instrumentation comes in, all the APIs comes in. Then you started to have all the different architectures, like Intel, x86, x64, X, okay, x86 64, 32 bits Intel, all the ARM processor series, and then you have the 8086. We have even emulate MS-DOS, MIPS, Linux, Mac OS, like what I mentioned just now, EDL, UEFI, and then we build all kind of debugger that they can connect to chilling, and then all the different kinds of extension. So there are a few small things that we would like to share. We just released STM32 module into a chilling. It's still very primitive. We are good enough to emulate STM32 F1, F7, and F4. And then, of course, the topic today that we're going to focus us on, it's going to be the EVM smart contract series. So these are the few things that we would like to cover today. So, of course, when it comes to EVM, none of these emulation tools or framework able to do EVM. So instrumental EVM, I guess we are the only one that able to run EVM bytecode with instrumentation on the framework level. So none of these project able to do it. So just to do a very quick recap, all right. This is a framework, not a tool. So the entire idea is we wanted the community to build all different kind of tools on top of chilling framework. So we have seen some very creative work, like EFI fuzzer. We have like some malware decoder, and then VAC3 emulator. We have seen quite a bit of sandbox here and there. And then we are still building, we are still making a Mac OS emulations complete. So hopefully when we complete the Mac OS emulations, the iOS and M1 series will be perfect. Okay. I hope perfect is a very big word to choose. So I do mention quite a fair bit of a couple of times on instrumentation. So to cut instrumentation short, this is instrumentation. So in a normal binary execution flow, you try to execute a binary that does a hello world maybe. So it will from A, B, C, D, E, F, and then along the way they'll call the library to run the hello world. So this is how hello world executions are being done. But instrumentation, what we're trying to achieve is if we already know this is the flow for a binary, and then we try to do analysis with some alteration along the way. So so for example, we want to start from B, and then we want to alter the memory. We want to do or alter a library function call. Then we will skip C. Then we'll go into D. Then we will do the CPU. We will update part of the CPU register, and then we're going to end in E. So these are the parts that if imagine you are dealing with a fairly large binary, then by cutting off certain parts of the the execution is going to save you quite a fair bit of time. And when it comes to fuzzing, this is totally comes in handy. You can fuzz with different CPU register, different parts of the memory. You try to update the function, everything it's possible over here. So this is instrumentation. Change the execution method of the executable file and try to change the binary flow and update or alter alterations memory function, CPU register, or whatever things that you want to do along the way. So when we are trying to build a chilling framework, all right, we are splitting it into three parts. So like what I mentioned just now, we support all the way from Windows, Mac, iOS, EVM, and then STM32 series. Then we have all the different types of architecture API that able to do instrumentation on the EVM itself. So of course the software mode, the last one, the software mode will be the ordinary the original chilling framework that we have with a CPU and OS. So the reason why we named this presentation as bringing the x86 experience into smart contract. The entire idea is we wanted to bring all the tools that you're familiar with, all right, you used to do with x86, and we wanted to bring the entire user experience from x86 engineering back into a smart contract. So you guys might heard, smart contract, you always have this all different kinds of bug that people started to steal millions and millions of dollars on the smart contract. So there are a lot of types of vulnerabilities. Whenever DeFi comes out, we started with the apps, and then this decentralized application, decentralized finance, and then that is where we things started to get complicated, as long as finance is involved. So on the very old data, all right, it's around 109 billion decentralized finance market cap as of April. All right, and then from 2019 to 2020, that's around 22 billion US dollar theft in the entire DeFi market. Don't get me wrong, all right, the 22 billion, it's pretty much based on the value of the tokens during that time. It could be if you wanted to convert the token value based on today's currency, depends on which token. It's gonna be a way more value in value USD in TEF nowadays. So a lot of tools have been published in the open source world, in the commercial world these days for EVM smart contract analysis. But the only thing, there are a few things that it's not easy to analyze when it comes to binary only contracts. We still do believe there's a lot of smart contracts come with the source code that is based on the best practice that you can do on either scan or whatever. But mm, there's still quite a fair bit of smart contract that you cannot get the source code. So the analysis is going to be way more harder. We all know that SIMEX, symbolic execution, is something you need a lot of human intervention to analyze the post report, the whatever things that are produced by a SIMEX engine. And again, a SIMEX engine also comes with quite a high level of false positive. So that is something that making a lot of people having trouble, having issue to analyze a smart contract. The last thing is like what I mentioned just now, regardless of what kind of tools that you're using, if you're checking the source code, if you're checking the analysis symbolic dynamic symbolic executions, you still need quite a fair bit of human intervention to come up with the proper analysis report. So, the official emulator, yes, there is a lot of official emulator for all the different chain, you know, all the way from Cardano, from Ethereum 2.0, EOS, Polkadot, and Binance. All right, we all know that 99% of the smart contract, and it's on EVM or WSM. Of course, Cardano is totally on a different path, okay, on the Haskell kind of mechanism. So that is something that we are looking at, and we might want to goes into that space. Of course, I miss out Solana. Uh, but what is missing over here is regardless of which coin and which blockchain that we are referring to. What is missing over here is most of this engine, they never provide a dynamic execution hook. That something is missing. There is no conditional executions. Okay. There is how should I put it? A hack and put together fuzzer engine that to fuzz a smart contract. So, in a nutshell, what they are trying to do, it's they are fuzzing they are fuzzing the entire emulation engine, and then they try to figure out the crash inside the system. Then we have things like, you know, there's no pattern execution check. There is no live debugging, of course, and then it's not a real instrumentation, so it's just a symbolic execution plus some workaround to do the instrumentation. And of course, the last thing is not a framework. So why not a framework? It's very important. It's this will allow other people to build more and more tools on top of the emulation engine that we have built. So that's the reason why we required uh uh that's the reason why we are always looking at a framework. Then we are allow other people to build more tools on top of our framework, just like how we designed, you know, how we mess with a unicorn engine, you know, how Queen mess with a keystone engine, capstone engine couple of years back until today. So there are certain mode that we would like to talk about. So we're going to start with the architecture, the smart contract, the symbolic execution layer, the EVM state, and the debugger. Okay. So once we receive a smart contract, either in a binary format or in a hex code format, you can always when you set up the architecture, you can always create account and create message. That is the two key APIs that we have provided inside the framework. Okay, so that is where you can start to create account. You can start to create account to tell what is the balance inside the smart contract. Of course, when you have smart contract, you need to tell the smart contract there are how many accounts over there, and then there are how many users over there, and each and every account have how many balance token inside the smart contract. Then inside the smart contract, that is where you started to able to put in the hook. So hook on instruction, hook on a specific address, or you can hook on a specific bytecode that you are looking at, and then you can start to do a disassembly function or the analysis function signature. So these are the example on we can hook on different we can hook on a specific instruction like push for. We can create a hook test on a specific address, right? And then we have things like symbolic executions. We are still haven't decided whether do we want to put in the engine or not. This is something that we are still pending. So by putting in a smart contract, then you can start to put in the symbolic executions. Then that is where you can start to load the CFG and generate the graph for symbolic executions. Okay, and then on the EVM states, then you can start to have all different kinds of EVM standard command. You know, get storage, get balance, get code. Okay, set storage, set balance. Then that is where you can start to do the transfer or whatsoever. So yeah, to delete the account, to set storage. This is all the EVM standard command that you can run with together with all the tools that we have provided. And then of course, to the last thing and the most important thing, it's the debugging mode. So we got a very small debugger that built into a chilling framework that you can debug all the way from the x86 tools to until the EVM code. So everything is built into one simple plugin that you are able to do step in, step over, continue, add breakpoint, list out the breakpoint, just like how you use your GDB in an x86 environment. Okay, so that's basically everything about the EVM engine. I guess you will be able to know more when we started to show you the demo on how things works over the EVM engine. So Kabal will be doing the EVM demo. He'll be showing you a step by step on how we can replicate or how we can redo certain parts of the DeFi money stealing project. We did not steal any money, but based on the old use case or old demos, old whatever things that happened before, we can replicate, and then we can re-implement into the EVM blockchain environment. So I'll pass this to Kabir.
Hello everyone, I'm Kabir, and I think it's time to do some demonstrations. We have done a lot of work since Black Hat Asia this year. So today I will show how we'll bring the x86 reverse engineering experience to smart contracts through a few demos. We have built a ETH smart contract emulator with instrumentation in the past. It is not just a virtual machine, it also simulates a lightweight blockchain environment. It's a platform that can be extended to the specific analysis direction. Based on this, we build a series of tools to enhance smart contract analysis capabilities. So first let me demonstrate the real-time EVM debugger. To use the debugger, users just need to enhance a chilling class and turn on the debugger option and emulate the transaction. We call it message in chilling EVM engine, and finally we can run it. Well, as you can see, there are 6 panels in the terminal. You can check the VM state and blockchain information when we debug the disassembler code. We can view all supported commands now by entering help. The debugger style pretty like GDB. Let's try to step the disassembly code. Entering SI or step into, and you can see the line of the PC is marked as red. We can see memory and stack changes in real time. We can set breakpoint to any address, and like here we set a breakpoint to 75, and we can use continue to execute to there. We also support to write memory and stack. Just use the write command. For example, we can try to write memory. To write memory, we need 2 parameters. One is address and another is values. Here we write 1, 2, 3, 4 to address 0, and now you can see we write it successful. We can check information use command inform. Like here we can check breakpoint, bytecode and memory. Here we can input inform bytecode, and here is the bytecode in memory view. You can also check all breakpoints we have set. Sometimes we want to step a lot of times and watch the memory and stack changes. We don't need to input SI or step into one time and one time. Just need to input a command named auto. You have two optional parameters. First is the count, means we can auto execute how many times, and the other is sleep, means how long it will wait every time. You see it step 5 times after we execute the command. We can also let it execute until the end automatically. Just remove the count parameter. You see it will stop at here. And because it is a deploy transaction, so it will write the runtime code to the memory, as you see at memory panel. Okay, now let's see a more complex example. This is a smart contract with reentry vulnerability. You can learn how it works through this picture. Basically, it will be recursive and create a child message again and again, then until the balance of smart contracts less than 1 ETH, it will be back. Okay, first of all, let's run the whole thing without using debugger. Initial time, the balance of attacker is 100 ETH, and after the attacking process, the attacker still almost 19 ETH. Now let's open the debugger option and see what is going on inside. Okay, now we are in the debugger, and you can see the message, the nonce of message is 0. That means the depth of message we are at is 0. And let's continue execute and see what will happen. The number of nonce increases from 0 to 40, and then it's reduced back. Then we input Ctrl D to create the debugger, and it will execute next transaction and return the output. I reopen the debugger, and this time we will make it slow. We need to use the optional parameter named sleep, same as the optional parameter sleep in the step in. Okay, now we can watch it clearly. And you can see it will jump between the victim contract and attacker contract. Now it will begin to reduce. And we can see what had happened in memory and stack. Okay, now the transaction execute finished, so we can use the Ctrl D to quick it. Next demo I want to show is smart contract symbolic execution. Use symbolic execution to detect the vulnerabilities of smart contract is very easy in Qilin engine. We just need to create a ETH VM, then load the bytecode to disassembler, create an analyzer, and after analysis finished, it will return a report. As you can see, we will create a panel for every vulnerability and include the vulnerability name, ID, function, and how we recurrent it. In the end, I want to show our smart contract security detection platform. The detection based on rules match. Now let me start up the back end and the front end. Well, that's it. We just need to input the contract bytecode and click the OK button. Here I have 5 contracts and let's see the detection results. If the rules match, it will be marked in red. You can see the detection is very fast. Users also can write their own rules by themselves. Okay, so that's what I want to show. See you.
So, thank you for the demonstration. So, before I end the entire presentation, all right, entire sharing session, some other things that we would like to share. It's finally we release a QEMU5. We didn't release QEMU5. For the hell we're talking about. Finally we release a Unicorn 2 that integrate with QEMU5, so you have the complete CPU architecture that's supported by a QEMU5. There are some other things that's still in the roadmap. So we are still looking at Android Java bytecode layer instrumentation. Something rather big, but we are still not. It's in the planning, but nothing has started yet. We did a bit of work on a host implementation, forward syscall to host implementation. It's something that we wanted to do. We got a bit of achievement, but the code is still rather ugly. We still haven't decided should we add into the core of chilling or not. We are cleaning up iPhone OS, Mac OS M1 emulation support. This should be rather quick. I do think we should be able to finish before Q4 of 2021. Obviously, we'll be finishing faster than COVID. unlock, period. Uh, we are still looking at Windows emulation. I think if you have followed our so-called little podcast on our YouTube channel, we should be we talk about this, and then we wanted to find a way to fix this thing up as soon as possible. All right. We released the smart contract engine. We released EVM, and I heard there are some other groups working on the WASM. So hopefully, we'll be seeing this engine real soon. We released the MCU engine. Yes, we are still working on a lot of stuff on MCU. So please do feel free to join us and give us a bit more pull requests on the project. So before we try to take in any questions, all right. Well, I'm not too sure how do we take in questions from the virtual conference, but you can still always come over and ping us on the Telegram group. Drop us a Twitter message. All right. Of course, it will be more responsive in the Telegram group. We got more people over there. A lot of people will be able to help you if you have any issues on Chilling Framework. Always go to our GitHub repo, star our project. That is part of the KPI that we know you like our project and you appreciate our project. So yeah, always come to our Telegram group, and then look for us and ask us if you have any questions. So all right, that's all for today, and thank you very much.